Here we have a problem. Factor completely. 2x cubed plus 6x squared minus 3x minus 9. First, we try to factor out the greatest common factor. Now, what is the greatest common factor between these four terms? 2x cubed, 6x squared, minus 3x minus 9. Well, the greatest common factor here is just 1. So we don't get a factorization of the greatest common factor here. So we wonder, could this be a prime polynomial? The answer is no, it is not prime. Even though the greatest common factor is 1, this polynomial is not prime. Observe that if we multiply x plus 3 times 2x squared minus 3, we obtain 2x cubed minus 3x plus 6x squared minus 9. If we rearrange the terms as 2x cubed plus 6x squared minus 3x minus 9, we see that our polynomial is the result of this product. So that means our polynomial is not prime. It does have a factorization. So we have to ask the question, how can we get this factorization? Well, let's try the following. Let's observe that in our polynomial, we have 4 terms. Let's do the following. Let's look at the 2 groups. The first 2 terms and the last 2 terms. So let's group those. First 2, last 2. Now, factor each of the groups completely. 2x cubed plus 6x squared. Greatest common factor is 2x squared. And we're left with x plus 3. In our second group, we see a common factor of negative 3. So let's take that out. Minus 3. Then we're left with x plus 3. At this point, we realize that we have created a common factor of x plus 3. So we factor it out. It is the greatest common factor of those 2 terms. So we obtain x plus 3 times 2x squared minus 3. Okay, so in this example, we have just experienced the idea of factoring by grouping. Notice that we have 4 terms. So we created 2 groups, the first 2 terms, the last 2 terms. Let's try some more examples. Factor the given polynomial by grouping. In other words, let's factor using this technique we just employed. Number 1, 10x cubed plus 25 x squared plus 6x plus 15. So here we have 4 terms. We're going to try a similar approach. Group the first 2 and the last 2. form two groups. In the first group, we get to factor 5x squared. That's the greatest common factor. And we're left with 2x plus 5. Check 5x squared times 2x, 10x cubed. 5x squared times 5, 25x squared. In our second group, we are able to factor 3. The greatest common factor of the second group is 3. So we end up with 3 times 2x plus 5. Let's observe that after we factor each of the groups, we create a common factor. That is the key of this method. After you group, you're looking for a common factor. In this case, we have 2x plus 5 is a common factor. It happens to be the greatest common factor of those two terms. So we factor it out. So we end up with 2x plus 5 times 5x squared plus 3. Let's try it again. Another example. This time we're going to try factoring x cubed minus 2x squared minus 5x plus 10. X cubed minus 2x squared minus 5x plus 10. Okay, so let's try it again. We're going to try factoring by grouping. Let's try grouping the first two terms and the last two terms. In our first group, we get to factor the greatest common factor, x squared, and we're left with x minus 2. In the second group, the greatest common factor is 5, but if we just factor 5, then we're left with negative x plus 2, which is not quite a common factor here. So let's try this second group again. We do get to factor out 5, but we should factor the negative as well. So let's try that. Let's factor out negative 5. What are we left with? We're left with x minus 2. Let's check. Negative 5 times x is negative 5x. Negative 5 times negative 2 is plus 10. Now we get a common factor. X minus 2 happens to be the greatest common factor of our two terms. So we factor out x minus 2, and we're left with x squared minus 5. In some factoring problems, we get further factorization. This one, however, it's not designed that way. At this point, x squared minus 5, we're going to consider it a prime, as there is no factorization with integer coefficients that will produce this product. Let's try another one. Number 3, we have x squared plus ax plus 2a minus 4. The theme here is factoring by grouping. So we try creating two groups. Let's try as before, first two, last two, and see what happens. First two, last two. In the first group, we can factor x, and we're left with x plus a. In our second group, we can factor out 2, and then we're left with a minus 2. We didn't get a common factor, so we must conclude that this way of grouping doesn't work. Grouping is successful only when you get a common factor between your factored groups. And in this case, we don't have common factors. So what does that mean? What can we do about it? Does it factor or could it be prime? Let me suggest that if I were to make some rearrangement here, I could possibly get two different groups which after factored gives a common factor. Now let me observe here that x squared minus 4 factors because it is a difference of squares. And then here we still have ax plus 2a, so plus ax plus 2a. Now, as I said before, x squared minus 4 factors is a difference of squares. So let's try that. X plus 2, x minus 2. Now, in this second group, if we consider this our second group, we can factor out the a. And it becomes evident that this maneuver worked. The rearrangement was capable of creating two groups where after each of the groups is completely factored, you have a common factor. So then you factor out the greatest common factor, the common factor, which in this case is x plus 2. So you end up with x plus 2 times whatever's left, which is x minus 2 plus a. Okay, so in this exercise, we have come across the possibility that you might need to rearrange terms for the grouping method to be successful. Let's try one more example. Let's try number 4. I'm going to erase the board to write number 4 on the board. So we have x cubed plus x squared minus 3x minus 27. Okay, so could we group the first two and the last two? If we group first two, last two, here is what we get. X squared, x plus 1, minus 3 times x plus 9. We didn't get a common factor, so it looks like this way of grouping is not going to work. So let's try rearranging terms. Now when you rearrange terms, you're looking for groups, two groups where factorization of each group is possible. Right now I think that I can factor the x cubed minus the 27. The question is, will we get common factors? So we know how to factor x cubed minus 27 because it is a difference of cubes. So we use our difference of cubes formula. So we get x minus 3, x squared plus the product, which is x times 3 or 3x plus 3 squared, which is 9. Okay, so we're done factoring our first group. Our second group, very simple. Common factor is x, so you take out x, and you're left with x minus 3. Success! We have a common factor of x minus 3. We proceed to factor it out. So we get x minus 3 times, what's left? Well, we get x squared plus 3x plus 9 plus x. Now we can combine like terms. 3x plus x becomes 4x. Okay, so that's our factorization. Now, there is a possibility that we're not done factoring. What about if this second factor here is a quadratic polynomial? Could it factor? Now, in this lesson, we are not considering the problem of factoring the trinomial, but if you were to try to factor this, you would end up concluding that this trinomial actually cannot be factored, so it is prime, so our factorization is in fact complete.